All right, and we are back at GraphQL Scale. I hope you had a chance to recharge, get a drink, have a chat, because this is our last stretch of talks for day 2. We've got 5 more amazing talks coming at you. And to start with, we have the amazing Maria Lucena, Director of Architecture at Fidelity Investments, to come talk to us about determining the right architecture when adopting Apollo Federation. Maria, how's it going today?
Hi, good. Thank you.
All right.
Thanks for having me, guys. Should I get started?
Yep, sorry, you're good to go.
Thank you. So, my name is Maria Lucena. I'm representing Fidelity Investments. I've been doing software development for about 13 years now, 7 of those at Fidelity. I've been mainly in the financial services industry. I did a little bit of freelancing for a while at the beginning of my career, but now I'm fully dedicated to back-end solution and now architecting. I'm originally from Venezuela. Boston was my second home for a long time, and I now reside in Philly. I have 2 beautiful teenage boys with my husband of 18 years. I'm a pet parent to 2 cuties, and yeah, that's a summary of who I am. Now I'm here today because this past year I was lucky enough to have been given the task to explore how Apollo Federation or how Federation, GraphQL Federation, can help Fidelity achieve its goals. We've examined different ways of implementing that with Apollo, and we've examined other tools. But the solution I'm presenting here today is focused at Apollo Federation and other tools around that. With that, I'll get started with our agenda, and then we'll move through each of these phases. So you're here because you're interested in determining the right architectural design as you adopt Apollo Federation. Maybe you're not 100% sure it is for you, but I do intend to arm you with the tools and options for how to do that, to help it and to help you decide if it is indeed for you and your company. We'll be first observing a planning tool that we leverage at Fidelity. That's the Business Architecture Framework. This is proven to deliver customer value while keeping the business going and driving innovation. As we design our graphs, the business should be reflected in it. Domain-driven design can help your teams realize expressive schemas by representing the domain model in the type system. Once you have decided on how you're going to implement your distributed graph, Apollo Federation can help you realize that. At each step of the way, we're going to be examining a POC that we've been driving at Fidelity for just testing the boundaries of Federation. That's the financial planning application. I am part of the wealth management group at Fidelity, and this particular capability presented us with enough challenges that we thought it would be good if we could prove that you can do solutioning with what we had in place at the time, which is an application that is in production as a BFF. If we could prove that we could bring this into the federated system and maintain the same capabilities, then we were pretty confident that Federation was the right thing for us. So hopefully at the end of this talk, you'll have some tools, some starting tools to get you going in this journey. First, let's talk a little bit more about the planning before we start thinking about the technical portion of things. As I mentioned before, at Fidelity, we trust the business architecture framework to help us realize our business goals. The Business Architecture Guild loosely defines it as a framework made up of business blueprints, scenarios, and business architecture knowledge base that interrelate to provide a foundation for the business architecture. Where business architecture gives business and technologists a complete view of your organization and a way to communicate effectively so that you can translate business strategy into actionable initiatives. With this technique, those that are involved can ensure that the technology is aligned to the business strategy, which it leads to people working together and speaking the same language and hopefully a more successful experience. Next, we should consider, because in the business architecture framework, business capabilities are pretty important. It's kind of like at the core of things, much like it is in Federation. So what are capabilities? These are the things that your business does or can do. In the context of business architecture, capabilities are the actions performed on business objects. So those are the nouns that make up your business language. This should be ubiquitous across your organization. Therefore, a business capability represents a unique action in your firm, regardless of your business unit. So these are the building blocks that make up your enterprise. Now, when you adopt this mindset, everyone involved is no longer hyper-focused in a single deliverable because you have a holistic view of the business. Then you can create a more reusable system because ecosystem, because now you're designing with awareness. What's happening at other parts of the organization? How is what I'm bringing to the table unique? And that will help you, especially when you have a super graph and things need to be uniquely or be expressed accurately within the context of the organization. So at this time, we can observe the POC that we've been working on. This is the financial planning proof of concept and the layers that make it up to date. It is a BFF. We have been using GraphQL at the organization for a few years now, as I mentioned before. And if you can observe here, there are multiple layers that make it up. So because each experience might be, while you have some modules that might be reused, there is a lot of duplication. There are a lot of multiple layers involved. And so this leads to a more complicated architecture. You have more network hops and all of those complications. My apologies for my dog. Most of this, the APIs today, among the things we want to accomplish is a flatter architecture that closely follows the capability model and continues to support our customer needs without causing any disruption. I apologize. So this is the customer view of that POC. And hopefully this brings into perspective how a simple view like this can, at a large organization like Fidelity, requires a lot of orchestration. While you do have, this demonstrates how the customer in session can look at a goal, where they are at that goal, and then some information that is in here, also some advice given to the customer. So it might look simple for the customer, but in the end, there's a lot going on the back end. And so this, going back to that concept of capabilities, it's a great way of demonstrating how you can cross domain, you can cross different boundaries with a federated system and still keep things transparent to the customer. So while we were going for, yes, we want to move to Federation because Federation has proven to help large organization and it has a lot of different benefits. But it's not just for the sake of moving. The BFF works, right? We have proven we can get these complex experiences in place and have some level of reusability and achieve the goal that is needed by the business using a BFF. And we weren't just simply going for swapping a tool. We were going for that larger picture, right? We want to have a super graph. We want to be able to have a single system where you can view all of your capabilities in one place, which also leads to less duplication, more scalable unified graph, and faster delivery of functionality. However, we were mainly going for a way of enforcing capabilities and domain relations and expressing better the complexity of our domains while accurately representing the business. So one way of thinking about that is at Fidelity, we have many different types of accounts. If your system, if your engineers, your teams, whoever is involved in planning and implementing things is aware of all the different types of accounts that can exist on a system or customers, then as they add new capabilities to that system, they have an awareness of what is out there and can create more expressive graphs. At this point, now we can turn our attention to the design portion of things. At Fidelity, we have been using for a long time. Some of our teams trust the time-proven tools, principles, and patterns of domain-driven design. That structure leads itself to a distributed architecture. What you're looking here on the left, it's the monorepo holding a BFF. That's the definition of a BFF. You see a segregation by apps and libraries, where the libraries are holding domain services. Each of those domain services, as it is today, and this is also a concept borrowed from NX tooling, which is used for managing monorepos. Those domain services are the ones that are holding the definitions of the GraphQL services. So there is the resolvers are there, anything that is accessing backends, and then or your data sources, and then there is a subgraph of sorts. There's a sub-schema that is defined with each of those domain, and the type definitions there are related to that domain only. There are some common types that are defined elsewhere, which are used across this domain services. But what this lent to us, this was a quick way to move towards a federated system, because we had already things separated by concern. So all I had to do to prove this was to take each of those domain services and expose them as subgraphs and front that with a gateway. And so very quickly, we were able to do some minimal syntax changes in the schema themselves, just to add the federated sugar on them and have a federated ecosystem running pretty quickly. So domain-driven design can help support that federated system better, because part of it, yes, while federation, changing your schemas to make your entities federated is kind of like the simpler part of things. What can be challenging as you go across teams is just finding patterns and finding a way to how we solve this. How do we go about doing this? We have a lot of different teams. So if you divide your code in a way that it's not only good for Apollo Federation, but it's also good for it as an engineering practice in general, then that can help. That can also help as you progress. It is now time to take a look at the graph itself. Apollo has bestowed the community with a plethora of documentation, so I won't go into the details of how to federate your schemas, but I definitely advise to take a look at what they offer. My layperson's take on it is Apollo Federation is a sophisticated solution for managing distributed graphs. Now, at Fidelity, we understand that GraphQL does not solve for everything, but what it does solve, it does so really well, which is why the Apollo client, Apollo servers have been part of our production flows for a long time today. We also know that implementing something naively doesn't allow the technology to grow to its full potential. We have had some growing pains with this, and we had at the Apollo Summit, we had another talk on some of those learnings. A distributed architecture, complex systems, and a desire to continue to implement our APIs with GraphQL has brought us to Apollo Federation. Separating the schema by domain and then bringing the system back together into a unified graph gives us the power needed in our ecosystems. We're currently experimenting with managed and manual composition. And in my humble opinion, the Apollo Cloud does a really good job at easing the process of managing things at scale. It is worth mentioning that while federation, federating a graph is not a silver bullet, it does not solve for everything. So as you move to a distributed system, the complexities of that will come with it, having a distributed architecture, right? So I have been in multiple discussions where there is a comparison. Do we need to distribute our graphs yet? Like it's this worth putting in a federated system? That I guess is a case by case discussion. You'll have to, if you have multiple teams, if you think that having a unified graph or having a monolithic system will then have a negative effect in your evolution or the growth of your company, then definitely go for federation. There are other things to consider. But just like anything else, weigh your options. So as we went through this experimentation, a few patterns evolved, and it's how using the tools that I mentioned before, we discover and identify these patterns. That is how we're going about implementing Apollo Federation or Federation, GraphQL Federation at the firm. So core entities, this is the simplest pattern, right? I have a monolithic graph and I'm going to a federated system. So how do I decide to separate things? Obviously, we're now separating by concern, right? But at the core of things, you have to identify your entities. What are your main players? Going back to that language of, business architecture, what are the nouns that make up your business? So those will most likely be your entities. There are others, depending on your scenarios, which is where you'll have to start discovering what are the things that I need to share and extend across different subgraphs, because as you distribute your system, that ease of keeping things together, you lose that. So then those challenges will start to become evident. But identifying your core entities will give you a good place to start, will ensure that you have enough segregation of things, and then you can keep going. And as I mentioned, the documentation, Apollo's documentation is really good at showing what is needed for the syntax and what is needed on the back end for your resolvers. The second pattern is contributing fields to core entities. So an easy example here is for us, we have goals, which is in the business context is more like I'm saving something either for college or for retirement or for a student loan. That's a goal, right? But each you may have multiple goals and a single goal with different progresses. So we had this latest goal progress field that needed information. It's actually the relationship is you have a goal that has a latest goal, an array of goals, and then we needed to expose a field that only demonstrated the latest goal out of that array. So we extended the goals entity in the goal progress subgraph. So now we have the goal subgraph, goal progress subgraph, with warranted having two separate subgraphs. And in that second subgraph, which is the goal progress, we extend the goal entity. So here we're contributing fields to core entities. In Federation 1, the language was extend. Federation 2, which is what we're using, is contributing fields to entities. The second one, similar to this, it expands on the same idea. Here we have goals and accounts. Goals, the goal subgraph or the goal entity has an array of accounts associated to it, but it doesn't hold, the goal subgraph doesn't hold the details of those accounts. Accounts, however, does hold that information. So if we want to get the details of each of those accounts, we would need to extend the goal entity and add that information in the account subgraph, which is where the data resides. For that, in this scenario, we need extra information other than the main ID, identifier of the goal in the account subgraph in order to resolve the goal account details field. So if you have this in one runtime, you could easily potentially add any fields that you want from the goals, because everything is running together. When you have things separated by the network, then you need to tell the orchestrator, which in this case is the router or gateway, that you require more data from a different subgraph. That's where the requires directive comes into place. It helps you tell the orchestrator to bring extra data so that you can resolve a field. That is quite powerful because more complex scenarios will potentially require a lot of data from other fields, and we've proven you can bring lists from, say, goals into accounts, that you can play around with the types that you need, but you can basically, with the requires directive, fetch a lot of arbitrary data from other subgraphs. The fourth pattern builds on that, and the difference here being that in this scenario, I have three subgraphs. Experience subgraph does not need to extend either account or customer, but it needs to borrow data from it to resolve its fields. So I don't want to enforce a relationship between entities that should not be aware of each other. I just need to use the data to resolve values. So again, that requires directive, external, and that is also shareable directive put together, allow you to solve for that sort of scenario. With that, this is the financial planning federated system, moved to Apollo Federation. This is a flatter architecture. You can clearly see where things are. There is less network hubs for a customer as they're resolving their data. And for us, it represents better the capabilities of the business. I hope that you enjoyed the talk. Once again, business architecture framework for planning, domain-driven design for your design portion of things, and then Apollo Federation to help you realize that distributed graph. Whatever your journey is, I hope it is a happy one. Thank you.
Awesome. So as we wait on questions in chat, I kind of want to know when you were looking at things and doing this exploration, was there ever any real pushback against the idea of federation, or was it kind of obvious from the start that like this was like the path forward for your particular needs?
There has definitely, we're still in the process of it's a cultural change in a way, right? I think that a lot of different teams at Fidelity see the value of federation because up until now, BFFs have been used for solving things, right? For making use of what GraphQL. GraphQL is not for everything. So where we do want to use GraphQL, but we have a sprawl of different APIs to bring together, the BFF makes sense. Now that we have a lot of BFFs, it's like, okay, BFFs creates a lot of code redundancy. So federation feels like the next best thing, right? There are some people that are completely sold on it. There are other people that are like, oh, do I need to change again, move to something new? Do we need to learn this again? But with our discovery, because we have these monorepos and we already have things segregated by domain, and we are using that concept of domain separation of things, it really made a lot of sense for the teams that have that segregation or that separation of concern in place to move to federation without creating a lot of cost. So when it comes to, for some teams, it's a lot more easier to move to that. Other teams that are still in the process of creating their APIs are just learning and are interested for sure.
Nice. So kind of along the way, it's been, everyone kind of felt that they had like a grasp on GraphQL, and now it's like, oh, you want me to learn this new, like deeper version of GraphQL. Do they enjoy the freedom that they get from being able to manage some of this on their own from this kind of segregated perspective?
Yeah, we're still working through how, stewardship, right? When you have a large organization, you have a lot of people that are like, well, we do it like this today. Can we continue to do it like that? It might make sense if you are keeping a small graph, but as you having a bigger graph, then you need to really share this. And for that, we need to have a strong body, a strong stewardship concept, and kind of like a cultural buy-in. People do feel that, yes, this should help, but at the same time, it's a bit frightening because of Fidelity. We have multiple teams right now. We have about 100 or 200 graphs, APIs using GraphQL separately. And the idea of just like bringing all of that together, just the idea of accounts coming together to a super graph, it's super daunting. But we're excited to tackle it. We feel at the end of the day will be more of a people challenge than technical. Apollo provides a lot of good tools for your teams to manage that. But even on top of that, yes, that cultural challenge and getting that stewardship iron out will make people feel more comfortable about engaging.
Amazing. All right, well, let's get some virtual applause in the chat. Looks like we don't have any questions for you at this time. So thank you so much for sharing these insights with us today.
Thank you.